Hello, today we will study the application of potentiometer. Okay, in our syllabus there are two applications of potentiometer. First one is to compare EMF of two cells, and the second one is to find the internal resistance of the cell. Okay, let's do the first one, to compare EMF of two cells. So to compare the EMF of two cells E1 and E2 using a potentiometer, we complete the electrical circuit as shown in the figure. So that means in order to compare the EMF of two cells, we have to draw this electrical circuit. So this is potentiometer. So I have just copied this diagram from the previous topic, that is potentiometer. So this is the potentiometer. So here we need two EMF nah? So in order to compare, see, two cell means we need two EMF. So this diagram I can modify it. So this is B nah? Point B. So instead of writing like this zigzag, so I can write in a straight. Okay, so I will just delete this one and connect this B here nah? So this is point B. So in previous topic also I have made two diagram nah? Second this is the second one. Okay, the second diagram. So now here we need two cell nah? So now this voltmeter we don't need here. Okay, now here I will connect two cell. Okay, two cell E1 and E2. So here two one, two, minus. So this side is plus, side is plus, this side is minus. So I will connect this with the help of two-way key nah? Key means switch. Okay, two-way key. So let's see, 1, 2, 3. This is two-way key. Okay, and now I will connect this. In two-way key there are three points nah? 1, 2 and 3. So I will connect this with galvanometer and then jockey. Nah? Okay, this is the diagram nah? Okay, now see, I have written here the description. So the positive plate pole of both the cell are connected to the terminal A. So this positive of both the cell is connected to A nah? this A. So let's say cell 1 has EMF E1 and 2 has EMF E2. The 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 negative pole of the two cells are connected to terminal 1 and 2 of a two-way key. Nah? So negative side is connected to terminal 1 and terminal 2. Nah? So E1 is connected to terminal 1 and cell E2 is connected to terminal 2 of the two-way key. While its common terminal, this point 3 nah, is the common terminal of two-way key, is connected to a jockey. Nah? So this point 3 is connected to a jockey through a galvanometer Ga. Through a galvanometer Ga. Okay, this portion is finished. So this is jockey. Okay, jockey is Ga. So why we are using galvanometer is also an electrical device used to see the direction of current. Nah? That means it is used to indicate whether the current is flowing or not. Okay, if it deflects, then the current is flowing. If it does not deflect, then current is not flowing. And an auxiliary battery, this point, an auxiliary battery means the main battery of EMF E. The main battery is this one, the auxiliary battery of EMF E. Of EMF E. Okay, the auxiliary battery of EMF E and an ammeter A, rheostat RH, and a one-way key K. That means an auxiliary battery of EMF E, ammeter A, and rheostat RH. Nah? So this is rheostat RH and a key K, and are connected between the in terminal of A and B. So they are connected between the in terminal of A and B. Nah? So this is connected between A and B, right? So this side is B, this side is A. So in physics, don't just write the diagram. Okay, you have to describe the diagram also. Most of you are not describing the diagram, so that is why I don't give marks. Last year also I have not given any marks for those who have not write anything about the diagram. Now a constant current is, see this one, now a constant current is passed through the potentiometer between the 2 point A and B. So due to this battery, constant current is passed between, here we have to pass the current nah, between point A and B. So the current is coming from this side and it will go that side. Okay. And the current is constant by using rheostat. So the purpose of rheostat is to make a constant current. Okay. Now when the plug is put in the gap between the terminal 1 and 3. So terminal 1 and 3, where is terminal? So now, okay, this is what? Two-way key, nah? Two-way key means switch, okay, just like your light switch, nah? But it has two-way, okay. So now we have to open this first terminal 1 and 3, nah? This one, okay. In first case, we have to open switch on this key 1. This portion we have to switch on, okay. So see it here, when the plug is put in, nah, that means when the plug is put in between the gap between terminal 1 and 3, that means 1 and 3 connection, nah, switch on, okay. 1 and 3 on, that means current can, now that means this current can pass through this one, nah. Here it cannot pass because here it is off, nah. So that means first we have to switch on this one, nah. So or connect between 1 and 3. So of the two-way key, the cell of EMF E1 will come in the circuit, right? So because E1 is this one, nah, E1, so it is in the circuit, nah, it is making a complete circuit, whereas this E2 is not making a complete circuit because here it is cut off, nah, it is not connected. First, see here we have, in the first we have to connect this 1 and 3, nah. Now when 1 and 3 is connected, E1 is in the circuit, okay. Now after connection this, we have to slide this jockey J, nah, over this wire, okay. Okay, after connecting switch this 1 and 3, we have to move this jockey over the wire to find a balance point. Balance point we will get when this galvanometer shows 0 deflection, nah. Okay, sorry, here this should be connected to this one, nah. So let's say this J, this point is the balance point, which is at a distance, let's say L1, nah. Let's say here at this point we find the balance position, okay, and this length is, let's say it is L1. So okay, that means suppose that the balance length of the wire between A and J is L1, nah? And X is the resistance per unit length of the wire. X is the resistance per unit length of the wire. That means per unit length, nah? One length, okay. Suppose if we measure in centimeter, 1 centimeter, 2 centimeter, 3 centimeter. X is resistance per unit length, means 1 centimeter resistance is X, nah? So 2 centimeter resistance will be 2X, nah? 3 centimeter resistance will be 3X, because in 1 centimeter the resistance is X, and we know that resistance is directly proportional to L, nah? So for L length, the resistance will be X into L, nah? Because for per unit length the resistance is X, nah? So for the entire length L, the resistance will be XL. So this X, in this case, our length is how much? L1, nah? So the total resistance over this, length A to J, nah? The total resistance will be X into L1. Okay, this will be the total resistance between A and J. Okay, A and J, nah? L1. In this case, it is length is L1, nah? Okay, now, so E1 will be, E is what? EMF, nah? EMF means potential, nah? So from Ohm's law, V equal to what? IR, right? So I is a constant current, that is I, nah? I is flowing, right? How much current is flowing? I current is flowing, nah? And R is how much? Resistance will be X into L1. Okay, so that is why E1 equal to X into L1 into I. So this is equation 1. Now for next step, okay, in first step we connect 1 and 3, nah? Now remove this 1 and 3, disconnect it. Okay, now disconnect 1 and 3 and then connect 2 and 3, nah? See, when the key is put in the gap, now when the key is put in the gap between terminal 2 and 3, after removing it from the gap between 1 and 3, nah? So now remove 1 and 3 and connect 2 and 3. Now when 2 and 3 is connected, E2 will be in the circuit, nah? And E1 is not in the circuit. The cell of EMF E2 will be included in the circuit, nah? Now for here also the balance point, after connecting we have to find the balance point. Okay, nah? Let's say in second case, in first case it is L1, let's say in second case it is L2, balance point is L2. Okay, so the total resistance will be X into L2, nah? In this case, in case 2. Okay, so similarly E2 will be equal to V equal to IR. R is X into L2, nah? Now divide equation 1 and 2. Equation 1 is E1 divided by E2, nah? So E1 divided by E2 equal to X L1I X L1I divided by equation 2 is X L2I. Now X cancel, I cancel, so we will have E1 by E2 equal to L1 by L2. Now measuring L1 and L2, the ratio of EMF of the two cells can be found, nah? So by measuring this L1 and L2, we can easily measure because here we have scale, nah? But we don't know the EMF E1 and E2. If we know L1 and L2, we can easily find the ratio of E1 and E2. So this is the comparison, so we can compare E1 and E2, nah? This is the comparison of EMF of two cells using potentiometer.